Alright, continuing our practice problem number 1, number 21. 3m all over 2m plus 1 plus 11m plus 7 all over 2m plus 1. Okay, so this is the addition of fractions, meaning we have to have common denominators, and then you add the tops or the numerators, right? Combine any kind of like terms. So to give this intermediate step, that's what the tops turn into. We can go ahead and just do that because the denominators are the same. And so the actual answer is going to be 14m plus 7 all over 2m. Okay. And if you remember back, our last steps are always to check and see if we can factor and reduce. And in this case, we can. We can factor a 7 out of this, and it leaves us with, force of habit to always write the x. And those cross off, so the answer is just 7. Alright, just 7. Number 22. Number 22 says simplify, and this one is subtraction. Another very commonly missed question. So there's no x there. Minus 4y all over y squared minus 4. So we're good to go because we have common denominators. But this negative is where the issues occur. You have to distribute this negative. So what this is going to turn into is 5 minus 3y minus 7y, because it's this one and this one, plus 4y. Right? People usually just make this one negative and not both negative, all over y squared minus 4. And let's actually combine the tops. I'm going to go and put my variables out front. So positive 4 and negative 3 is just a y. And then minus 2 all over y squared minus 4. And then, as you can see here, we should always try to see if we can factor, and we can. We can factor the bottoms. Y minus 2, y plus 2, that's a difference of squares. Those cross off. Now we're dividing here, we're not subtracting, so nothing's turned into 0, so the final answer is 1 over y plus 2. 23. Um, 23 says solve. And so we're looking at 2 all over 5x plus 4 all over 5 equals 2 all over 3. Now this is an equation. So I have the option of clearing the fraction. So I still need to find the greatest common factor. And so we're looking at 5, 5, and 3. So that's going to be 15 is the number, and then they each have to have an x. Right? So what happens is I'm going to multiply everything by 15x over 1. Okay, that's the greatest common factor, and I'm going to get this one times this one is 30x all over 5x plus 60x all over 5 equals 30x all over 3. And then reduce. Leaves me with 6 plus 60 divided by 5. That goes in there one time. It leaves us with I want to say 12x equals 10x. Alright? So now we will go ahead and get all the variables on the same side. You can see how nicely this cleared up. Equals negative 2x divided by negative 2. I'm going to put the x on the other side, and it equals negative 3. Alright, 24 is a work problem. And it says, Roberto can tune up his car in 2 hours working alone. His brother Juan can do the job in 3 hours working alone. How long will it take them if they work together? These, going back, this was a particular type of question that we set up, and it's always going to be an example of their combined rate over their individual rate. So basically you have Roberto and Juan. Okay, so their combined rate is x. We don't know what it is. That's the question. And it's all, so Roberto can do the job in 2 hours. Juan can do the job in 3 hours. We want to add their rates together, and we want to figure out how long it would take them to do one job. These are always equal to 1. Okay, and so now, if you see here, this is an example again where I can clear the fraction. So the greatest common factor here is 6. I'm going to multiply everything by 6 over 1. And this turns out to be 6x over 2 plus 6x over 3 equals 6. And this equals 3x plus 2x equals 6. And then we get 5x equals 6, dividing by 5. Okay. And then from here, they usually want these as mixed numbers. So I would have to divide, and it goes in there one time, leaves with a remainder of 1. And so that is 1 and 1/5. Right, hours, I believe they were talking about. All right, last two for this section. 25, that last one was 24. 25 is a complex fraction. And so a complex fraction means you basically have fractions inside of fractions. And you can see right here what I'm talking about. Okay. And so what you basically have to do, that's an 8, not a 9. What you have to do is clear all the little fractions. So you look at all the little denominators, and you multiply by that greatest common denominator. Kind of did this notation right here. We're technically multiplying by 1 here, and it's going to be 4a squared. Everything gets multiplied by 4a squared over 1. So this is going to equal 4a squared all over 4 minus 4a squared all over a squared all over 4a squared all over 2 plus 4a squared all over a. I just multiplied that to every fraction. And coming over here, because we're running out of room, this one, the 4's cross off, so I get a squared. This one over here, the a squareds cross off, and you can see what happened. I got rid of all the little fractions. Over here, it leaves me with a 2a squared. And then over here, I get rid of 1a plus 4a. Now let's see if we can factor here. And we can. And take out a GCF here. Actually, it's 2a. We get a plus 2. And those cross off, and our final answer is coming down here is a minus 2 all over 2a. All right, last question for this section on rational expressions. This is 26, and this is 3 over 5 all over x over 5 plus x over 4. So this is another example of a complex fraction. So looking at this, I look at 5, 5, and 4, so the GCF in this case is 20 over 1. So I'm going to multiply that by everything, and that turns into 60 over 5 all over 20 over 5, so there's an x up there, plus 20x all over 4. Coming down here to do the reducing, that's going to be 12 all over 4x plus 5x. And these are actually like terms, so I can add them. That gives me 9x. Well, I can reduce 12 and 9, and that takes out a 3 out of both of those. So the answer is 4 over 3x. Most people are going to leave the answer right there.